Welcome to this podcast episode brought to you by AGS Agriculture Global Solutions, your partner for better farming practices.
It's great to be here.
So today we're going to look at something that, well, if I brought it up at a coffee shop with some veteran planters, I think I'd get laughed out of the room. I mean, we spend our whole careers trying to feed the root system. We worry about fertilizer placement, water tables, soil compaction.
Right. All the standard stuff.
So if I come along and say the best thing you can do for a mature palm is to go out there and deliberately cut the roots, you'd probably tell me I'm crazy.
It definitely sounds like bad advice at first glance. I mean, we're all trained to protect the asset, right? And the root system is the main asset.
Right.
But we need to shift our thinking a little bit. We have to stop looking at roots as just, a static plumbing system that just sits there. It's a living, growing engine. And like any engine, if you run it for years without a tune-up, well, parts get worn out, efficiency drops, and you start burning fuel without getting the power you need.
So we are talking about root pruning, engine maintenance for the oil palm, basically.
Exactly. And we're not just talking about, hacking away at the soil with a hoe blindly.
No.
We're looking at a very specific set of data here.
Yeah.
It's about 4-year-old palms, the PPKS variety specifically. The research wanted to answer a simple but pretty risky question.
Which was?
Can we unlock more nutrients from the soil just by manipulating the roots without adding a single extra kilogram of fertilizer?
No, that's the part that gets my attention. Without extra fertilizer. We all know input costs are only going up. So if we can get the tree to do the work for us, that's a huge win for the margin. But before we get to the how, let's talk about the why. Why does a 4-year-old palm even need this? What's happening down there that makes the roots inefficient?
Well, once a palm moves out of that juvenile phase, that root architecture becomes incredibly complex. You've got 8 distinct types of roots working down there.
8 types.
Yeah, the primary anchor roots,
Yes.
secondary horizontal ones, the fine tertiary feeder roots. It's a massive network. But here's the problem. Roots age.
They get old and tired.
In a way. As a root gets older, it undergoes a process called suberization.
Okay, break that down for us.
Think of it like a callus forming on your hand. It's this waxy, corky layer that builds up on the outside of the root. Biologically, it's there to protect the root, transport water.
Yeah.
But that corky layer makes the root hydrophobic.
It repels water.
It literally repels water.
Yeah.
So you end up with a root system that's taking up space. It's consuming carbohydrates to stay alive, but it's not actually absorbing nutrients efficiently anymore.
So it's a lazy root. It's taking up space in the factory, but not doing any work.
Precisely. It becomes more of a storage organ than an absorption organ. And this brings us to the most fascinating part of the biology here. The tree is actually willing to pay to get new roots.
So what do you mean pay?
The source material highlights a statistic that is, honestly, it's mind-blowing. About 20 to 40% of the carbohydrates a palm produces through photosynthesis.
Yeah.
They're not used to grow the trunk or the fruit bunches.
Wait. Up to 40%. So the tree works all day in the sun, making sugar, and then just throws almost half of it away.
It doesn't throw it away. It invests it. The tree excretes these carbohydrates directly into the soil through the roots.
Okay.
These secretions are called exudates. It's a whole cocktail of organic acids, amino acids, sugars. The tree pumps this stuff into the rhizosphere, the soil right next to the roots, to feed microorganisms.
It's paying the microbes.
It's a bribe. The tree feeds the bacteria and fungi, and in exchange, those microbes break down organic matter. They mineralize nutrients like nitrogen and phosphorus so the tree can absorb them.
Wow.
It's a symbiotic loop. The tree farms the microbes, and the microbes feed the tree.
That's incredible. So how does cutting the roots help this whole process?
Okay, so when you prune a root, you mechanically sever it. You trigger a stress response. It's called compensatory growth.
Right.
The tree senses the damage. It thinks, hey, I lost a feeder. So it rushes to repair the damage by sending out this flush of new, white, highly active feeder roots.
And these new roots are hungry.
They're very hungry, and they pump out significantly more of those exudates, those sugars and acids, than the old corky roots ever could.
So by cutting the old roots, we force the tree to build new ones, which then feed the microbes more food, which then releases more nutrients for the tree.
You've nailed it. The study showed root pruning increased the concentration of organic acids in the soil by over 25% and sugars by about 18%.
Yeah.
You're essentially jump-starting the soil engine.
Okay, the theory is solid. I'm sold. But let's talk practice. If I send my team out to the field tomorrow and tell them to start digging, they could do a lot of damage if they don't know the parameters.
For sure.
This study tested specific variables to find the sweet spot. What did they look at?
They looked at two main levers, depth and intensity. For depth, they compared a control sow doing nothing against digging to 10 centimeters and then digging deeper to 20 centimeters.
Okay, 10 and 20.
Then for
Yeah.
intensity, they looked at how much of the circle they disturbed, so 25%, 50%, or 75% of the area.
And we need to be clear on the location here. We're not digging right up against the trunk
Yeah.
where we don't want to hit the bowl.
No, absolutely not. The research focused on a radius of 1.5 meters from the stem. That is the active zone.
1.5 meters.
Yeah, you go closer, you hit the anchor roots, and you risk destabilizing the whole tree. You go too far out into the inner row, and the root density just drops off. 1.5 meters is where the feeder roots are concentrated.
Got it. 1.5 meters out. Now let's get to the results. Nitrogen. It's usually our biggest fertilizer cost. If we can unlock free nitrogen from the soil, that's money in the bank. What did the data say?
The results were very, very specific. And they might surprise people who believe that deeper is better. The highest soil nitrogen content, hitting 0.30%, was found when they pruned at a depth of 10 centimeters.
Okay, 10 centimeters.
With an intensity of 50%.
So shallow cultivation,
Yeah.
just the top layer,
Yeah.
and doing about half the circle.
Yes. And when they went deeper to 20 centimeters, nitrogen availability actually dropped.
Why is that? I mean, you'd think digging deeper exposes more soil, cuts more roots. It should create a bigger reaction.
It seems logical, but it's about where the biology actually lives. Nitrogen's very mobile, but the microbes that process it, the ones eating those exudates, they thrive in the topsoil, where there's plenty of oxygen. If you dig down to 20 centimeters, you're disrupting the soil structure too much.
Yeah.
You might be causing leaching, washing the nutrients down below the root zone, or you could just be disturbing the microbial habitat too aggressively.
So 10 centimeters is the Goldilocks zone.
It's the Goldilocks zone. It's enough disturbance to stimulate the roots, but not enough to ruin the soil ecosystem.
Okay, so 10 centimeters deep, 50% of the circle for nitrogen. What about potassium? For fruit bunch weight, we need our K.
The story for potassium was almost identical. The high FK levels were also found at the 10-centimeter depth and 50% intensity.
Really, the same sweet spot.
It seems that this specific combination is just very efficient at redistributing nutrients in the soil profile.
And phosphorus. P is usually the tricky one, right? It gets locked up in the soil so easily.
Phosphorus was slightly different. It also preferred the 10-centimeter depth, but it responded better to a lower intensity, about 25% disturbance.
So phosphorus wants a gentler touch.
It does. But, practically speaking, you can't tell a worker to dig 50% for nitrogen and then come back and do 25% for phosphorus.
Well, that's impossible to manage.
Exactly. So the takeaway is that the 10-centimeter 50% protocol is the best all-around approach. You maximize nitrogen and potassium, and you still get a significant benefit for phosphorus. The key message here is really about what not to do.
Which is?
Do not go down to 20 centimeters. Across the board, digging that deep resulted in lower nutrient availability compared to the shallow cut.
That is a huge insight for labor planning. I mean, digging 20 centimeters is heady work. Scratching the top 10 centimeters is much faster, much easier. You're skimming, not excavating.
Correct. You are cultivating, not trenching.
Okay, I want to shift gears a little bit to the environmental side. We hear a lot about soil carbon these days. Sustainable farming, keeping carbon in the ground. Did root pruning help with that?
This is where we hit a bit of a trade-off. The study confirmed that root pruning did increase carbon stocks compared to doing nothing.
Okay.
Again, that compensatory growth means the tree is building more biomass underground.
So that sounds like a win.
It is, but there's a catch. The highest carbon reserve, we're talking nearly 17 tons per hectare per year, was found in the 20-centimeter depth treatment with 75% intensity.
So the deep, aggressive cut that was bad for nutrients is actually the best for storing carbon.
Technically, yes, but we have to look at the cost. While that deep, intensive cut stored the most carbon in the roots, it also caused the highest level of physiological stress to the plant, and this is crucial, the highest emissions of CO2 from the soil.
Explain that mechanism. We stored carbon, but we also emitted it.
When you open up the soil that deep, you increase soil respiration. You're introducing a massive amount of oxygen into the subsoil.
Right.
The microbes go into a frenzy consuming organic matter, and they release carbon dioxide as a byproduct. So even though the tree is building these big roots, the soil itself is exhaling a huge amount of CO2.
So net-net, it might not be worth it.
Exactly. Plus, 75% intensity at 20 centimeters is a massive shock to the tree. For a production plantation where yield is the priority, the recommendation stays firmly at that 10-centimeter level.
Got it.
It provides a moderate boost to carbon stocks without the massive stress event and the nutrient loss we saw with the deep cut.
It just keeps coming back to moderation, doesn't it? We're not trying to traumatize the tree. We're
Yeah.
just trying to wake it up.
Wake it up is the perfect phrase.
Yeah.
And the study noted this wasn't just happening underground. They measured trunk diameter and tree height, and the pruned trees grew faster.
Oh, interesting.
That tells us the tree isn't just frantically repairing damage, it's actually accessing enough extra nutrition to build structural biomass.
So we have the what prune the roots. We have the where 1.5 meters out, 10 centimeters deep. But there was one more variable in this study that I think is arguably the most actionable piece of advice for a field manager. It wasn't about how to cut, but when.
This was fascinating. It links agronomy with, well, simple physics. The researchers measured soil CO2 emissions at different times of the day,
Yeah.
morning, noon, and late afternoon.
And I'm guessing it changes as the sun comes up?
Drastically.
Mhm.
Emissions were significantly highest around 5:00 p.m.
Late afternoon, why?
It's an inverse relationship with humidity. In our climate, the morning is humid.
Yeah.
As the day goes on, the air dries out. The study found that as humidity dropped, soil CO2 flux shot up. Essentially, when you expose that fresh, moist soil to the dry afternoon air, it dries out very quickly. The soil pores open up and the carbon just escapes into the atmosphere.
So if I have a crew out there doing this work at 3 or 4 p.m., thinking they're being productive, I'm actually doing damage.
You're likely drying out the very root tips you're trying to stimulate.
Mhm.
You are basically baking the microbiome.
Wow.
The exposed soil at 20 centimeters, or even 10, loses moisture incredibly fast in the heat of the afternoon.
That is such a simple operational shift. Tools down at 1 p.m. or just focus this task on the early morning blocks.
Exactly. If you are going to disturb the soil, do it when the moisture and humidity are high. It protects that microbial environment. The study explicitly advises doing this work in the morning to minimize carbon loss and moisture stress.
Okay, let's bring all this together. We've covered a lot of technical ground exudates, superization, CO2 flux. If I'm a smallholder or a field conductor listening to this and I want to try this on a block of 4-year-old palms, what's the protocol? Let's build the checklist.
All right, let's call it the 10-centimeter protocol.
Step 1, location.
1.5 meters. You measure 1.5 meters from the palm stem. That is your working zone. Do not dig near the trunk, and don't waste time in the middle of the inner row.
Step 2, depth.
10 centimeters. This is crucial. Calibrate your tools and structure workers. You're cultivating the topsoil, not digging a hole. If you see them going down to 20 centimeters, stop them. You're losing nitrogen and stressing the tree.
Step 3, intensity.
50% of the circle. You don't need to ring the entire tree. You can do a semicircle or maybe 2/4 on opposite sides. The goal is just to stimulate about half of that root zone. Leave the other half intact to keep the tree stable while the new roots grow.
And finally, the most important one, timing.
Morning only. Do this work when the air is cool and humid. Avoid the hot, dry afternoons at all costs.
And what's the expected payoff? What am I getting for this labor cost?
You are triggering a biological chain reaction. You cut the root, the tree floods the soil with sugars, the microbial population explodes, and they mineralize the nitrogen and potassium that is already in your soil but, currently locked up.
Right.
You get better nutrient uptake, a greener canopy, and a structurally stronger tree.
All without buying extra fertilizer.
Correct. You're substituting biology for chemistry. It's a management input, not a cash input.
I really like that approach. It empowers the farmer to use the system that nature already built. Before we wrap up, was there any final nuance in the study about, say, the weather?
Just one important note. This study was done in a tropical environment with wet and dry seasons. The advice to avoid dry afternoons applies doubly to dry seasons.
Okay, so if you're in a drought period,
Do not prune roots.
that makes perfect sense. Don't stress a tree that's already thirsty.
Exactly.
Yeah.
You want to do this when there is adequate soil moisture to support that flush of new root growth. If the soil is bone dry, the new roots will just die, and you've damaged the old ones for nothing. You have to wait for the rain.
Use your judgment. Farming is never a robot's job. It takes observation.
100%.
Well, this has been a really useful discussion. I think we often treat the soil as just a sponge that holds the plant up, but it really is a living stomach that needs to be kept active. And a simple change, 10 centimeters instead of 20, can completely change the nutrient profile of your farm.
It really highlights that precision matters. More isn't always better. Deeper isn't always better. Smart is better.
And on that note, we'll leave you to go inspect your own root zones.
There's a whole world of activity in that topsoil.
Indeed there is. One final thought for the road. The study noted a strong correlation between carbon stocks and vegetation health, basically how green the canopy is. It suggests that by farming the soil biology, you aren't just fixing the roots, you're building the factory that produces the yield for years to come.
A healthy root system is the best insurance policy a farmer can have.
Remember to visit our AI farming assistant at cropdrive.ai to learn more on how to increase your oil palm yields and incomes. Thanks for listening.